Hey guys. All right, we're going to be doing 1.4 on the worksheet today. And let's try and prove the following properties of trees. Any pair of vertices are connected by exactly one simple path. Now let's start this out by looking at information what we're given. So let's look at some properties of trees. One is that they're cyclic, they have no cycles, and they're connected, meaning that all the vertices in a tree are connected. And if they're all connected, that means that there exists a simple path between them. So let's break it down further. What is a simple path? Where there's a path between them. We're trying to prove that there's exactly one, but what is a simple path? A simple path means that there are no repeated edges and no repeated vertices. So using this information, let's try and solve the problem. I would say, considering that we're trying to prove that there's exactly one simple path, one strategy that I think is a good idea would be to try contradiction. Let's say that there's more than one simple path. And for this case, just for the sake of this example, we'll say that there are two. So we will make this graph here to kind of help illustrate this. Let's say we're trying to get from point A to point B, right? To say that there's more than one simple path to get to from point A to point B within this graph, um, one way, one way, one simple path to get there would be to go straight from A down to B, but we're trying to say that there's more than one simple path. And what this would mean is uh, that the paths are going to have to diverge at some point. They're going to have to disconnect from each other, and then they would have to reconnect at that same point. Like you'd have to be able to go like from this, like here, from A to B, or there would have to be some other way or somewhere along one of these vertices where you disconnect, go a different path, and then still somehow end up at B. So an example would be that we can go down from A to B, and then we can also traverse back up and go from B to A. However, while this is like a path from A to B and a path from B to A, now they're two paths. The problem is that they're not simple paths, or they're not really even paths. It's more like a walk because we've repeated the use of all of these vertices and all of these edges. Or I'll use color to make that a little bit nicer. We repeated the use of these edges and these vertices. So we can't really call that a simple path. And so now we have proved that there is only one simple path from vertices, two vertices, yeah, any pair of vertices in a graph. So now let's look at B. Adding any edge to a tree creates a simple cycle. So we also, from A, we have this statement that we can use that any pair of vertices are connected by exactly one simple path. So let's draw out an example again here. Same one as before. A to B. We know that Or let's not go what we know. Let's say we have a path here from A to B, right? And that they aren't connected by some edge directly, but there exists like a path between them. Then if we were to add an edge here, we'll prove that that makes a cycle. So let's go over what's in a cycle really quickly. In a cycle, we have no repeated vertices, no repeated edges, and then the start has to equal the end. So from A, as we know that there is a unique path, only one unique path from A to B. If we were to add an edge between A to B, right? Now, let's use a different color. We can traverse down to B, and with the new edge we've added, we can go back up. We've ended back up at A. We've not repeated the use of any edges, and we've not repeated the use of any vertices except for the start equaling the end. And that follows exactly what the definition of a simple cycle is. And now we have proved what we wanted to do, that adding an edge in a tree creates a simple cycle. So we can go from A to B, then back from B to A. And that's it for 1.4, the graph worksheet. Thank you.